Okay, this is COMP1050 Animation 2D Tools, and it's week 5, part 5. Talking about accepting player input. I'm going to try and break it up a little bit for you this way so that it's not as bad when it comes to watching the movies, because there's a lot of detail here. We talk about player input. We just talked about the assignment, and I said move around with your keys, right? Well, there's two ways to get it. You can get mouse input, right, which is one way we can get player input, or we can get keyboard input. Well, mouse input is really kind of interesting because what we're doing is, if I want to show you the mouse location, and let's look at mouse input.fla. So I'm going to go back to Flash, and I'm going to open up mouse input.fla. And again, if I run it, I have my mouse, here it is, and it tells me my X and Y coordinates on the top left corner of my screen with this little text file, right? Well, this is really handy, right? So Flash can easily tell you where your mouse is, just like Python or other languages. If I hover over the circle, however, I get this hover effect going on, right, with my mouse. How do I do it? Let's take a look at the code. So first of all, I've got a text field, right? It's my mouse location text, but that's the text field itself. I make it so that it's not selectable. Otherwise, it wouldn't look like a pointer. I add it to the stage, the top left corner of the stage. I can put this wherever I want, by the way. Let's leave it there for now. I add an event listener, right? It's an enter frame event. Who remembers what an enter frame event is? An enter frame event is almost like you're listening for every frame, right, for the movie clip. So if the movie clip or your FLA file is set to 20 frames per second, I am polling the stage 20 times every second, right? The enter frame event listens 20 times per second. That's what it does, right? So now I'm saying every time there's a frame, that I'm getting a frame, tell me what my mouse location is, 20 times per second. This, think about it, is your game loop. Your enter frame event allows you to have a game loop. It allows you to continuously listen, pull your interface over and over again every frame. Okay, it's the beginning of our frame loop, our game loop anyway. So here we have a mouse location. That's our text file, right? And we're changing the text property, and we're using two things: mouse X and mouse Y. They are fixed properties of the mouse. That's it. Mouse X and mouse Y, you know where your mouse location is. Very, very simple, very powerful. What we're going to do is we're creating a new sprite with the circle. Okay, so here's my sprite. I'm creating, and by the way, if you notice, my library is empty. I don't have anything in my library. I'm creating my library items here. My sprite, all right, .graphics, .begin fill. I'm filling it up with a black color, right? I'm drawing my circle. Its location is 200 by 200, 200. X and Y coordinates, with a radius of 20 pixels, right? My alpha transparency begins at 0.5, which is 50%, right? And I'm adding the child to the stage. Excuse me. I change on rollover, right? I created another event listener called mouse event rollover. So I'm actually, when I roll over the actual circle itself on my sprite, right? My alpha changes to 1. So in other words, my circle from 50% alpha goes to 100% alpha. It becomes opaque, right? When I roll out, I do another event listener, and my circle goes back to 50% alpha or transparent, right? So that's how I create that transparency effect, okay? There's many ways I can do that. That's just one way that we've done it here. But the great thing is it's following me around. The circle is following me around. Right? Or sorry, this program tells me where my mouse is anytime I want, which is really, really important. Okay, before we move on to keyboard input, do you remember that we had this follow around, almost like a circle that we used in Python, and wherever I moved my mouse, the circle followed me around? Remember that? We had a little program like that. And we used that as the basis for MailPilot, where we had a spaceship. It was underneath my my cursor, and wherever I move my spaceship, my cursor, my mouse, that's where my spaceship would go, right? Maybe even too fast, I would say, right? Well, I've kind of duplicated that here for you. So if I've actually added that in, if you go to Flash, and if you open, this is one to open and take a look at what I've done. And it's called, if I'm not wrong, move circle.fla. Okay, I'm going to run it, and this should look familiar to you. Aha! Right? Remember how we did this in Python? How did I do it? Right? Well, there's no cursor, number one. Right? So let's talk about that. If I leave this area here, there's still no cursor. This is bad. Right? Well, I've added in a failsafe. If I press my Q button, right? If I press the Q button, then it should, what it should do is it should allow me to see my cursor again. Right? There it is. There's my cursor. And if you notice, it kind of lags behind me. There we go. It's trying to follow me, but it's not fast enough. Why isn't it fast enough? Anybody? Huh?
FPS.
Frame rates, for sure. Frame rate is the key. My frame rate right now for the movie is set to 30 frames per second, right? We can probably boost it to 60 frames per second in Starlink, right? I wouldn't recommend you boosting it beyond 30 on a browser window. It's just not going to happen, right? So let's try that out. Let's try it in my browser. How do I see it in my browser, right? I'm going to close it off. If you go to your code archive, right? Here's my code archive. In here, I have move circle, and I've already exported it to an HTML file. Here it is, right here, right? If I run it, right? I'll open it with Chrome, right? Here it is, and there's my circle. It's actually working here with ActionScript, right? Now it's a Flash file. If I right-click onto it, it shows me it's a Flash file. It's not exported HTML5 like, right? Because I'm using ActionScript. I'm not using JavaScript, right? So my circle's moving around my browser right here, and it's following my mouse. If I click Q, right, or my mouse comes back. Here's my mouse cursor. Let's take a look at the code that I used. This is one of mine. And again, all I've done is gone into Python, right? Gone into Python, taken the code from Python, hint, hint. Example, you want to take some code from Python that you've already worked on, and you want to use it here in ActionScript. It's not that challenging, okay? I use the mouse.hide method to hide my cursor, so my cursor can disappear. You need to do this most likely if you're going to use a mouse-type game, mouse-based game, right? Here, I'm creating something called a circle cursor, right? Which is actually a sprite. Sprite is equal to new sprite. I'm using the sprite class, right? I'm not using classes at all, right? This is the most simplest form of creating a sprite. By the way, if you remember back in Python, we use classes for everything, right? We haven't used one class so far, right? We don't need to yet. Circle cursor .graphics.beginFill. So I'm filling it in with a blue color, right? And I'm defining the circle. My circle is being drawn, right, at the top left corner of my sprite. Top left corner of my sprite, and it's going to have a radius of 25 pixels. I'm going to end fill, and then I'm going to take my circle cursor, and I'm going to define it wherever my x and y, my mouse x and mouse y position is where my circle cursor is going to be drawn. I'm going to add it to the stage, right? And then I'm going to add in 2 event listeners. One for my mouse event, mouse move. So when I move my mouse around, I'm listening for the cursor. I could easily have used my enter frame event too. That could have worked as well. Instead of listening for my mouse move, I could have listened for an enter frame event, but I'm not going to. When my mouse moves around, I use my update circle cursor method or function. Here it is. And all I do is I update. Here's my update for my circle. So wherever my mouse moves, my circle tries to follow. That's all it's doing. My x and y match my mouse x and my mouse y. All right. I want to quit Flash. Have you ever tried to quit Flash so far with ActionScript? You can't do it. Can't do it, right? You can't quit the test movie, if you will. And you test the movie in Flash and try and create a command to quit, won't work, right? Why? Because we're in test mode. That's why. We're not in actual in display mode. The way to test this is my actual quit button here. I've created fs command is what it's called. We're going to talk about that later on. But I need to include system.fs command in order for me to use this thing. And I can perform a quit function. That's what it does, right? Now you have this code already. I'm listening for key code 81, which is the key code for my Q button, right? And then what I do is I show my mouse, because I want to show my mouse again, my mouse cursor, and I want to quit Flash. That's what I do. Well, let me show you how quit Flash works when I'm not testing. Okay, so here I am. I also have a move circle Swift file, right? Standalone Flash file. I double click on it, and here it is. Here's my standalone Flash file. And if you notice, there's no cursor, right? Except when I leave the screen. If I click on the Q button, though, it closes the Swift document down, right? And I've done that with fs command quit. All right, that's the way to do it, right? When you have a Swift document, standalone document. We're going to talk about other methods of quitting the document or quitting your game as we move towards more and more development, and we move towards using Starling as well. So that is a little test for you guys. I encourage you to take a look at FLA. Okay, so we've handled mouse input. Let's talk about keyboard input, right? So there's really two keyboard events that allow us to do continuous input. Remember, we talked about this almost like a hardware interrupt that we're looking at getting, right? You kind of need to use both these events, this key up and key down event. If you use both of them at the same time, actually what you do is you're polling for, you almost get that hardware polling situation going in Flash. So again, when I press the key down, I send a message. When I lift the key up, I send another message. And what I want to do is I want to continue listening for that key up or key down event, right? So here's the first one. I'm adding a key down event to the stage. And by the way, all key up and key down events, they're not added to a sprite. They're added to the stage. Okay, it's different than a mouse click. This is a key up and key down event using keys, right? So it's stage.add event listener. Then there's two ways of doing it. The first way is I'm going to listen for a character code. Okay, character code. And I'm going to say this, keyboard text.text key pressed is whatever. I use my string function from the character code, right? And then I output my character code to my text, right? If I want to know which key was pressed, kind of thing. I can also use a key code, which is like a character code, but it's not affected by the shift key, right? So a key code always gives you the same key input, regardless of which button he's pressed. So if I press A, I want to get an A code. Whether I press shift or not, it's going to be the A button I'm getting, right? That's what a key code does. That's what's different than a character code. If you want shift A, you need to use character code. All right, that's the difference. And you can always do the same thing with events. Also include control key, shift key, alt key. All those things allow us to use the character code. So let's take a look at this. So you have two events: your key down event, right, as an example, and your key up event, right? Both those events are important for us to make sure that we can do. We listen for key input. Okay, we're going to get back to that because keyboard input is one thing, but we want to be able to move around with our mouse. How do we do that? Let's talk about text input. So you want your player to enter in his name when he starts playing the game, right? What's your name? And you put in like, Big B, right? Or whatever you want to put his name is the guy who's playing the game, right? So he puts it in, right? You want to be able to get input from his text. Well, what you can do is you set up another text field, except this type, you change the input type or the text field type to an input. Text field type dot input. Once you put that in, now you can accept input into that field as opposed to just displaying the field as a label. All right. Problem is, you really have a problem. It doesn't really show where the field is, right? Like it doesn't show where, where this thing is at all, right? So what you want to do is you want to at least put a border around the field so that we know that he's entering data somewhere. And there's some basic options here, which I'm not going to go over. I'm going to let you go over it if you need to see how to do keyboard input or sorry, text input here. I'm just going to skip forward until we get to the exciting part, which is creating animation. Okay, so we talked about sprites already, but now we want to talk about sprite movement, right? Just like we did when we were using Python, sprite movement in ActionScript is very similar. But we're going to be using the enter frame event for this kind of thing. Let's take a look at sprite movement.fla to see how this works. Sprite movement.fla. Here it is. If I run the movie, right, this little guy is moving around the screen, right? And he's going to keep moving all the way to the right. So how is this done? Well, we have a couple of things in the library this time. We have our mascot, and we have our hero. Okay? Hero's like a mascot, except he's animated. Here is our hero. If I double-click on the hero symbol, and I go to timeline, he's got a series of frames that we've devoted to create this walk cycle, right? So this is his walk cycle. And I can keep going over and over again, but this is what's going to happen with him. He has a little walk cycle. Okay. I also, if you look here, I have a layer 15, which is probably like an ActionScript layer. If I click onto it and click here inside the Actions panel, I have a stop. Stop means don't let this animation go, right? I want to control the animation with ActionScript. I just don't want to run the movie because otherwise he'll just keep going. He'll keep looping and looping and looping, and I want that. I want to be able to control that. So we put a stop on his walk cycle as soon as we connect him. We've linked him to our ActionScript by creating this mascot. Hero class file. Here it is, export for ActionScript. We've actually created a linkage here in ActionScript so we can reference the hero object here. If I go back to ActionScript in the main timeline, here's the animation. It seems very, very simple to me, right? I create my hero object, right? Which is a instance of hero, right here. Here's my hero object right here. I put him on the stage at 100, 200. I add him on there. I connect him to the stage. I show him, basically display him on the stage. That's what add_child does. Now I add an event listener. Here's my game loop, if you will, my enter frame event, right? And when I do this, I start animate hero, which is my event handler. Imagine you have your enter frame event, and that which is it's the actual event listener, and then you have your event handler, which actually does something with the messages, right? So every frame, here's where I go. I want to move my hero X plus equals to 7, which means the hero is going to move across the stage to the right 7 pixels every frame. How many frames per second? Let's take a look. We're only moving at 12 frames per second, right? If I was to accelerate this to 30, which is typical of gameplay these days, and run it again, now he's much faster, right? The problem is, if I run it again, it looks too fast, right? Because his animation is made that way. It's going to keep moving forever, by the way. It's going to keep going off the stage. It's not going to stop when it gets to the edge or move back. So we haven't programmed that. Why is it too fast? And that's why we go back to 12, just for this example. Well, if I go back to the symbol in the library for hero, I only have one state 2, 3, 4, 5, 6, 7, 8 frames. So I've got 8 frames, right? And then those 8 frames are going to be gone, right? Because I'm going to go through. I do 30 frames per second. That means he's going to do his walk cycle 3 times in 1 second. It's way too fast, right? So what to do? How do I fix it? Anybody? I got a walk cycle, and I want to make it so it's more realistic. And I want to make it 30 frames per second. I want to extend my walk cycle 30 frames per second, or my frames, but I want to make it so that it's not crazy like he's walking, right? We're not talking about how many frames he's moving across the stage how many pixels he's moving across. We're talking about how many frames are being displayed in the timeline for his walk cycle. Right, how do we do that? How do we fix it? You could, well, in this animation here, right, you can actually add additional frames between the different states, right? So basically, he'll have, instead of each keyframe right now, each frame is a keyframe, you can add in extra frames between keyframes to expand the time he's in the same state. So he's not walking so fast. He's not changing states. He's in his walk cycle every frame. Okay, that's one thing we could do. Let's go back to the code. So he's moving across the stage 7 pixels per frame, right? And then what I'm saying is this: hero.currentFrame is equal to 8. I'm checking if my current frame is 8, then I want to go to and stop at frame 2. If I've gone to my last frame, I want to go back and to frame 2. Okay, go to and stop. And then I say hero go to and stop, right? And then where I want to go to is my current frame plus 1. So if I'm not at frame 8, I'm going to go to go to and stop wherever my current frame is plus 1. Okay, so if I'm at 7, now I'm going to go to 8. If I'm at 8, it's not going to get there. It's going to go back to 2. And if I'm at 2, I'm going to go to 3. And I'm at 3, and so the cycle continues. It's going to loop, right? It's one way of doing a looping a walk cycle using ActionScript code. Not the only way by any means. Okay. So again, here we've used this enter frame event and the basic sprite movement. We're animating them by using frame-by-frame animation. Why is this bad? Right? Well, it's frame dependent, number one. What we'd rather do, most likely, instead of making it frame by frame, is using a timer. That's much better. Let's take a look. So we've got 12 frames per second. We talked about the frames and how it walks across. But using timers are a little better. Think about timers as little message clocks, right? Every time, every tick of the clock, it's sending a message, right? So example, what we do is we can create a timer, right, for X number of milliseconds as opposed to frames, right? Because once we start talking frames, now we're limiting ourselves. The whole animation is based on how many frames are on our stage. We don't want that to happen at all. Okay, here's an example where I'm creating a timer. Timer is equal to new timer, and I'm creating a timer that's 1,000 milliseconds. So that's the first part. And then I'm going to create a new event listener. I'm going to add an event listener called timer event timer, a timer type of event, and I'm going to launch this timer function. This is the second part of the timer. So the first part is I create my timer, I define it as a 1,000 millisecond timer. So every second it's going to fire. That's what it's going to do, right? And then what I'm going to do is every second that fires, I'm going to create a graphic object, right? I'm going to fill a circle, and I'm going to take the current count. Current count is actually a timer property. It's saying, how many seconds am I now? It's going to keep counting. Am I at second 1? Am I at count 2? It's almost like it keeps track of the timer being used forever. So if I use the timer for 50 seconds, 100 seconds, 200 seconds, that current count property is going to keep increasing, right? So here's what I'm doing here. I'm saying, well, draw my circle, and where am I drawing it? I'm going to take my x coordinate, right, which is 10 times my current count. So it's going to move across the screen, a circle that's going to move across the screen every second. It's going to create a new, actually it's going to draw a new circle across the screen every second, right? And the radius is going to be 4, so little tiny circles. Then to kick it off, I got to use the start method to kick off the timer, or else it won't start. So there's 3 components. I create the timer, actually 4. I create my, my event listener, I create my event handler to handle my timing, and then I start the timer. That's why I create my timer in Flash. And you know what? You're going to need a timer for your project number 1. So you need to analyze how this works. Let's take a look at using timers.fla, the first one. So I'm going to open up using timers.fla. Here we are. Let's take a look at the code. So here it is, a new timer of 1,000 milliseconds. So every second, right, it's going to run the function, right? If I run it, right, here's the circles. 1, 2, 3, 4. It's going to keep on making those circles. These represent each second, right? And it's going to keep going forever. Every time the current count goes up, it's going to create a new circle. It's going to draw a new circle to the screen. Okay, that's pretty cool. Let's take a look at the next one, though, using timers2.fla. What does this one do? Well, here we go. Here's an animation, just like we did before, but now it's animating our sprite with the timer instead of the enter frame event. Let's take a look at how we do that. Well, here we go. So our function, our timer function, right, it starts, you know, what we're doing is we're using it to animate the hero, right, with our walk cycle. Let's check that out. Here it is. So here's our hero. I'm adding a hero. I'm putting him at 100 and 200. I'm adding him to the stage. I'm displaying him. I create my hero timer. And now my hero timer is happening at 80 milliseconds. How many milliseconds are in a second? 1,000. So I'm saying I'm going to be updating my counter. I'm going to be running my function every 80 milliseconds, which is 12.5 frames per second. That's what this is. So if I want to emulate frames per second with a timer, I take my milliseconds and I divide my 1,000 milliseconds over my timer to get my frames per second. Right? Think about it. Right? I want this to fire, right? 80 milliseconds every 80 milliseconds. So it's going to 80 milliseconds is going to be 12.5 times a second. Because if you take 80 times 12.5, you get 1,000, right? Let's try that out and make sure you're right, Tom, before you say it. I'm guessing. So here's my little calculator. I take 80, you know, multiply that by 12.5, and I get 1,000. So 12.5 frames per second, if it makes sense, approximately. If I want to get closer, if I want to go faster, then what am I going to do? Am I going to increase the 80, or am I going to decrease that number? I decrease that number. I want more. Instead of 80 milliseconds a delay, I want to make it so that it happens at 40 milliseconds or 20 milliseconds, every 20 milliseconds for it to happen. Here's the problem. What if I go to 1 millisecond? That's like 1,000 frames per second. 1,000 frames per second is crazy, right? It's too fast, right? So that can't be. I can never do like that fast. It'll crash my machine probably, right? But I could probably do 40. 40 milliseconds is like around 25 frames per second, right? No problem, right? So that's about 40. So again, milliseconds times whatever the frame rate is, and that's going to equal your thing. So if I want 30 frames per second, if I want to divide 1,000 milliseconds divided by divided by 30, right? I want approximately 33 milliseconds. Every 33 milliseconds, I want an event to fire. That's 30 frames per second, right? Let's go back. Not a lot of math here, but we got to think about it a little bit. Okay, and it does the exact same animation. All we've done is we've replaced the enter frame event with a timer, right? Time-based animation. So real time-based animation is actually quite cool. What we want to do sometimes is we want to kind of use a combination of both here, right? What I want to do is create a timer so that I say, here's my start time, right? I create a start time, and then I save that start time, okay? And then what I do is I make some calculations. I say, give me my start time, and then now every time I have an event, I want to get the new time, and I want to subtract it from the old time to get a change in the number of milliseconds that have gone by. How many milliseconds have elapsed? That's a different thing than a delay, right? Let's take a look at time-based animation.fla. Oops. So I have all these little exercise files for you, right? Because I think it's important for you to take a look at them, right, to analyze how they all work. If I run this movie now, here's what I get. I get a little circle or a sphere, and it's going across the stage, right? Let's try that again. So stage, my sphere goes across the stage, right? How do I do that? Well, oops. Well, I've created a timer, and I say I've used last time is equal to get timer. Get timer is like saying, what's the current time right now in milliseconds? It takes a number, it gives you the number, right? If I want to show you what that is, just to show you really quickly, so if I say trace, right, get timer, or last time, that's probably what I should do, right? And I run it now, it shows me that the milliseconds, it says the number 3, okay? To show you that number changing, I take this trace event, last time, right? And what I want to do is I want to put it somewhere else, like somewhere here in my function. Here it is. Okay, now I want to run it. So if you notice, the time keeps going. And it goes up quickly. There's a number of milliseconds. It's going to keep going infinitum. Right? If you notice back here, I'm going to go up to the top. It starts off at 93, 96, 107, 124, and so on. It keeps going up very, very quickly. Right? And that's the timer counting the last time. It's saying, what's my last time? My last time, my last time. I'm also using this time diff variable that's local to this function. It's a local variable, and it says, I want to get the timer now, and I want to minus the last time, right? Okay, and then my last time plus equals to my time differential, my difference in time. So maybe what I should do is look at the time diff, just to give you an example of what that is. All right, 16, 17, 19, 18. It's funny, it hovers around 16 and 17 seconds. How come? Milliseconds, that's what it is, right? Because it's my computer. My computer is able to function this fast as it can go. 17, 18 milliseconds difference in time between the time I pull, right? That's what it's doing. Okay. So what am I saying here? I'm saying my ball x, the x coordinate, is plus or equal to the time difference, right, times 0.1. Which means I take my time difference, instead of like 18 or 17, I'm dividing it by it's only 10% of that, right? So, I take 10% of the total time difference, right? So really, I can multiply it by 100. If I multiply it by 100, that's the real time, right? The actual time I have, 0.1, right? And then I actually get the real amount. So really, it's not 17 or 18. It's like 1,800 milliseconds have gone by, right? Or 1,800 cycles, if you will, have flown by. But I only want to move my mascot 17 or 18 pixels every time my function fires in my enter frame event. But my enter frame event is being affected, in this particular case, by my frames per second, which right now is 60 frames per second. So 60 frames per second, that means my event fires 60 times every second, right? Not 30 times per second, which is about once every 15 or 18 milliseconds. Okay. Timer-based animation. Physics-based animation. Now we're getting a little bit more complex, right? What we want to do here is we want to establish or emulate what it's like to have physics placed on a ball, right? Well, our ball, right, would normally in the real world would fall at 9.8 meters per second squared, right? Or 32 feet per second. But in real life, do we really need to make it 9.8 meters per second squared on the computer? Well, there's no meters on the computer. We have pixels. So now what we really want to go for is pixels per frame. That's more like it, right? And we gotta kind of set up a scale, if you will, right? So if we say 1 pixel is 1 meter, right? Then it'll fall a different rate as opposed to, 1 pixel is, 10 centimeters, right? You can adjust your scale for how fast an object falls through space. Right? In this particular case, if we did 1 pixel per meter, we use 0.0098 meters per millisecond, right? Because remember, each second is 1,000 milliseconds. So you take 9.8 meters per second squared and divide it by, or 9.8 meters, and divide it by 1,000, you get 0.0098 meters per millisecond, right? And that gives you kind of some kind of emulation of physics, right? You also need your change in y and change your x coordinates, right? Because what we want to do is we want to say, well, the starting velocity for your x is 0.2, right? So you're going across the stage at 0.2, right? 0.2 pixels. And then you're going to accelerate due to gravity 0.0098 pixels per frame. Okay? And this is where you get, once we've established that, what we want to do is we want to get timer. We want to do that get timer event, like the same thing as we did last time with the time diff and stuff. Except this time, what we want to do is we want to take my dy, add our gravity multiplied by our time differential, between ticks of the clock kind of thing, right? To give us that arc, right? Let's take a look at how it works. So it kind of looks realistic. Is this one? Oh, I just did that one. It is, which one is it again? Physics-based animation. Yes. Here it is. And we run it. Whoop, and down. So it looks like very similar to what a ball would look like, or the trajectory, the arc of an object going up and coming down due to, based on gravity working on it. Now again, if we look at our stage properties, we're still moving at 12 frames per second. If I change this to 60, right, now we're using real-time based animation, does that change anything? And the answer is it does. It makes it so that our the frames, we have way more frames per second, and what it does is it makes the animation a lot smoother, right? But again, 60 frames per second is pretty taxing on most systems, unless you use GPU acceleration. Okay. User interaction. So we talked about, I want you guys to have 8 directional movement for your game, right? Well, this is how you would do the mouse key. This is the arrow keys. The arrow keys are kind of 38 for up, 40 for down, 39 for across, and 37 for back, right, kind of thing, or left, right, and so on. If you go to movingsprites.fla, movingsprites.fla, and if I run it, I can use my arrow keys to move right or left. Now it's pretty boring, and it doesn't change position or facing, right? So this is kind of a problem. But if I keep pressing on it, it'll keep moving. If I press both of them, he'll stop. If I press both diagonals, he'll go to the top left, and diagonal left, he'll go to the top, bottom left. Sorry, top right, bottom right, top left, and he'll keep doing that as long as I press the buttons. So not bad in terms of movement, and it's pretty smooth. We're still only operating, right, at 12 frames per second. If I change this to 60, right, and I run it again, now it's much faster and a lot smoother, right? I'm not sure if I want him that fast though, but the reason why he's that fast is because, not just because of the frames per second, because remember, we don't want to fool with that too much, but what we decided to move him, how many pixels we decided to move him at a time. And again, we have 2 different event listeners that are going on here. For us to simulate hardware polling, we need to have both the keyboard key up as well as the keyboard down event firing at the same time. If we don't have that, if we don't have both those events, what we're going to have is a problem. We'll only be able to pull one side of it, and you won't get that smooth motion all the time. Okay? We also use a enter frame event because we want to be able to move the mascot around frame by frame. And we're doing it, look, his speed is 5 pixels. So maybe that's a little fast if I'm going at 60 frames per second, right? But typically, if I go back to something like 30 frames per second, which is more average, right? And again, I go back to his code here. Maybe what I want to do is reduce this to like 3. So maybe 3 pixels at 30 frames per second. And now when I move him, you know, he's a little smoother, but he's not quite as fast. He's a lot slower, right? And again, I'm using a set of if statements. If left arrow, then mascot.x is minus equal to the speed. If right arrow, because I've assigned left arrow and right arrow as constants, if you will, right? Here they are, left arrow, right arrow, up arrow, down arrow. Which one is being pressed? If one of them is being pressed, then you go left, right, so on, right? But is this really the right thing to do, or should I be doing it with a switch statement? And again, I leave that to you in terms of coding. Both are the same result. Switch statement might be better if you have more than 4 keys you're working with, right? Especially if you're having keys that do the exact same thing. Like for example, if I have, you know, my arrow keys and maybe another set of keys on my keyboard, like example WASD, or one of some other keyboard combination on the left-hand side, right? that kind of moves the character with the left side of the keyboard as opposed to the right side. I never said use the arrow keys in your assignment, right? All right. Let's go back. So again, what we want to do here is these three different event listeners. One for key down, one for key up, and one for the enter frame event so we can move our mascot, move our hero, if you will. Okay, what about dragging sprites around? We can do that too, right? We can move our sprite around by creating this mouse down and mouse up event. And we can use our, we can also need the enter frame event to do that. We can drag sprites around the place, right? Not a lot of call for it. It's different than what I did with the moving the mouse around, right? Because instead of dragging and clicking, it's just following the mouse around. The circle's following the mouse. So I'll let you explore dragging sprites around on your own. This is a key. Collision detection. Now we're almost there. We have some moving around, but now we have to talk about collisions. All right. So collision detection, we can use our enter frame event, right? Or a timer of some sort. Let's talk about the enter frame event, right? Every time a frame is happening, every time it's kicking off at 30 frames per second or whatever we set things to, we can use two different type of basic hit detection. Hit test point, hit test object. Those are the two types. Okay, there's a problem with both of them that you're going to see right away. And we're going to have to develop one a little better than these ones. Okay, but for now, these are the basic ones that are the ugly ones I talked about before. Remember way back in Python where you have the rectangular bounding box and you have two rectangles and they kind of intersect, and even though they're not really touching, they're touching, right? That's hit test object, right? Hit test point is where it detects your mouse over any point of an object. That's a different type of hit test. That's me detecting where my mouse is relative to the object itself. So if I want to see, well, is my mouse over the object, as an example, and I get a hit result, that's different than hit test object. Hit test point we'll never probably use in games. Hit test object as a basic hit detection we might use in games. All right? What we want to try and do is think about something like this. What about not using either of these collision detection methods and making our own? And what I mean by that is, if I think about it, I know the location of my object, and I can do two things. I can use the radius of the object that I'm detecting, so half the radius. So let's say my object is 30 by 30, right? Well, I know that half the width or half the height is 25, right? So if another object is the same, an enemy object is also 50 or whatever, and half the width and half the height is 25, right? Then I know that I have a hit radius. Before they come together, between the middle of my object and the other object, of 50 pixels. So if I know that they're less than 50 pixels away, there's a hit. It's got to happen, 100%, right? That's just basic if they're complete circles, right? But most often our objects are not circles. Our objects are differently shaped, right? So how do we come up with that? And we use a combination of both. Combination of both. And we'll talk about that later on, because hit detection in ActionScript, that's the one area that you either download a little library for yourself to use for accurate hit detection, or use something like Starling, right? Or something else like that, or calculate it yourself. Okay? But let's talk about this basic collision detection that we have with hit test object and hit test point. How does it work? Well, here's one basic one. We use hit test point, my mouse X and mouse Y position, right? And I'm checking it against this crescent shape, right? If this is true, then hit test point is true, is yes. Otherwise, it's not true. It's false, right? So again, I use my There is no boundary I'm using here. All I'm doing is I'm checking the exact location, right? There's actually one other one that we haven't talked about. It's bitmap. I can actually check the bitmap from one type of bitmap to the other. That's another, but it takes a lot of cycles from our calculations. So it's not really desirable for us to use that one. Hit test object works a little differently. It says, here's my star, one type of sprite. Hit test object with the crescent, right? The other object. And if they cross, you get a collision. Great for basic collisions, but bad if they're not square. Because we're going to get that problem where you have this, two squares, but the object's in the middle, and then they're going to collide. Or you create, if you really want to get crazy, multi-layered sprites like we talked about before, right? Where you have different pieces that are going to collide. So smaller groupings of sprites. So you have, if any one of these groups of sprites collide with any one of these groups of sprites, then you have a collision and you get more accurate. But still, that's not quite as good as doing measurements, almost like a radius. Hit test radius would be a great one. Between me, the distance between me and the next sprite, what's my distance? Okay, if I'm less than this, I'm creating my own little boundary, a little radius. I'm less to hit, right? That's the best way to do it. And whatever you do your calculations, do not use things like complicated calculations in your hit test, like square root. That's a bad thing to do when you're doing it every frame. Okay, it'll totally slow your machine down. Okay, external data before we stop. We talked about this morning about loading XML data in when we were using jQuery, right? Well, you can kind of use XML data and other types of data here in using Flash, right? Sometimes what we want to do is we want to listen for a type of data because we want to load in things like a high score, or something like that, right? And it's stored locally in the machine. So the way we do that is we do three things. We create a URL request, we initiate a URL loader, and then we add an event listener to listen for the event complete for the XML loader that we've created, right? So we're waiting for the loading to happen. Once it's finished, then we fire up this function, and the function, what it does is it takes the information, right, from our XML data file and prints it out or does whatever we want with it. Okay, I'm not going to go into how to do that. It's the same thing with saving local data. Saving local data, we create a shared object, and what we do is we take the local or information and save it to a local file. In this particular case, we call it my game data. Okay, I'm not asking you to do that for your project number 1, but I would encourage you to take a read, do a little bit of looking at this stuff if you're interested. We will cover this more as we go over it for the next couple weeks, but it's here if you want to take a look at it. Couple of miscellaneous game elements. Custom cursors. So we talked about this before. I just showed you a custom cursor, my circle. And you have to use that mouse.hide method in order for you to hide your regular cursor so you can see your custom cursor. So that's one thing we can do. And I kind of detail how to kind of create a custom cursor here. Playing sounds. This one's important because, hey, every time I hit something, I want to play a little sound. Well, how do I do that? Well, there's two ways. You can embed the sound in your game movies library, one, and then create a instance of that sound inside your ActionScript. Or you can load a file, like an MP3 or something, directly, right? The real easy, better way is to do it inside your library. That's just the easiest way to do it. You can do it both ways. One's just a little bit more complex than the other. So here's the first way. So you create the sound, we call it sound 1. We've created an instance of that sound in the library, and now we use it, and now what we want to do is, we don't play that sound yet. What we want to do is create a channel for that sound. So we create a sound channel, and that sound channel is going to be able to take that sound playing, and we can play that sound. So we create a channel called channel, and then I've embedded this sound1.play methodology in it. Okay? Or you can do it all in one line like this. This is the best way, the embedded version, right? Here's the more complex version. This is the way that you get sounds from you load a sound, right, in real time, right? I don't recommend this way. It's more complex. Both ways work, by the way. One way just works a little better than the other. So here's your sound 2 way, right? So I make a new sound. I have a URL request to load the sound from playing sounds.mp3, and then from there, what I'm doing is I load the sound from my request. So I've loaded it up, and now I play it. You know, it's a little bit more complex. More lines of code means a little bit slower. But either way, you want to play the sound in the end. Whether you play one way or the other, you want to play the sound. The challenge that we're going to have is, how do I play a sound and then play another sound on top of it, right? An example of that would be, I'm just saying, right? I have an engine of a tank, right? And it goes roar, 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 roar. And it's making a sound constantly, right? How do I keep playing it forever, right? So, and it only happens, my sound only happens when I'm moving. Okay, so I move, roar, 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 and then when I stop, it stops. Right? How do I do that? How do I stop the sound? And we got to look into that as we move forward. This is one of the things we're going to look into over the course of the next week or two. We talked about before. We talked about this creating a loading screen or a game start screen. But this is really a loading screen. Like if you have to load up all your content, and sometimes we need to do that. We load up a bunch of stuff, and we have a da-da-da, you know, your game is about to load, and we see that in the iPhone, on Android, everywhere. And all of a sudden it loads up, and now we're able to play our game, right? We do that because there's so many assets we're loading up, we don't want the player to think that the game is frozen, right? So let's take a look at loading screen.fla. And here we go. Okay. It's loading. Right? This is a big little graphic here, and it keeps loading, loading, loading. And if you notice, it was instant, right? Let's take a look at what it actually says. So we go to timeline, click the action script part. Sorry. Here it is. What I'm really doing is saying this. I'm going to stop the movie from running. That's the first thing I want to do. And then I want to add an event listener, an enter frame event. And I want to access this thing called load progress. So every time this thing is loading, I want to kind of put together this root.loader info in bytes. Well, it's so quick because I'm using a test movie that it's instantly loaded for me. But if you're on the web somewhere, you could simulate a slowdown of it loading up, right? Example would be this. If I was to publish this movie, so here I'm going to publish my movie, right? Here's my HTML format, and it's going to be the loading screen.html. I'm going to publish it now. Oops, that's not what I wanted. I'm going to publish it now. Publish it. There it is, published. All right. Now that I've published it, I'm going to go to, not there, my Finder window, courses, and in here, here's my loading screen.html file. Let's run this. Now, it's so quick still, you didn't really see it because that's how fast. Again, I'm loading it off my system. I'm not loading it off the web, right? So it's not taking much time. Let's try it again. So it's so fast, it was like, whoosh, right? Because the loading screen took so long. But sometimes what happens is it takes so much, we're loading so many bytes of data that we need some kind of loading screen as a delay, something that comes up and says, hey, it's coming. It's coming, guys. You're almost finished now. Okay, here it is. Right? So something to think about when we're, as we're building our code or building out our program, do we need a loading screen or some kind of loading wheel, you know, that kind of comes up, right? Okay. Random numbers. Can't have a game without random numbers, right? We need some kind of randomness to it, right? Well, for random numbers, it's so easy in ActionScript. All we need to use the math.random function, right? So if I go to randomnumbers.fla, just as a test, here it is. I run it, right? So here we go. It's run a bunch of times, and I've got a few results here. I've got a random number between 0 to 0.99999. It's 0.713 blah, blah, blah. A random number between 0 to 99.9999, 98 point blah, blah, blah. A random integer between 0 and 99, 4, and a random integer between 1 and 100, and 95. So a bunch of random numbers. How did I do it really quickly? Well, it's very simple. Var, I define a variable, random 1 is a number, and I use math.random. That gives me that 0 to 0.999, right? If I want it from 0 to 99.9999, right, I have to multiply by 100. If I want it to be an integer, I use math.floor, right, to cut off the numbers or round it up, if you will. Actually round it down, math.floor. And then I multiply it by 100, so 0 to 99. And if I want to make it from, instead of 0 to 99, from 1 to 100, I add 1 to it. So this is the way we make it. If I want to make it from 1 to 6, I want to roll a die, right, 1 to 6. I'll do the same thing. I'll copy it. And this time, I'll put 6 in here, right? And I'll make this 5. And I'll run it. Okay? So, this is 1 to 100. Let's try that again, Tom. 1 to 6. Run it. So 1 to 6, I get 1. I rolled a 1, which is bad. Let's try it again. 6. Let's try it again. 3. So random number generator is very, very quick. It's part of ActionScript. It's simple, dead easy, and we need it for things like random objects, you know, any kind of randomization we can think of. It's a pseudo-random number again. So remember, it's not 100% random, but it's probably going to be a lot more random than you would think for most objects. These guys are like chomping at the bit today to get in here. All right. Shuffling an array, I'll leave that for you to read. It talks about how to shuffle a deck of cards. And we're going to do some shuffling next week, but the code for doing that is right here. And what it does is it uses the array and array methods to shuffle things around, right? Just like we did in Java or even in Python. They have array objects have their own methods. Displaying a clock is kind of the same idea as using a timer, except what we're doing is we're going to get the timer and then we're going to divide by different numbers to provide seconds and minutes. And that's about it. So all the data that you need here is on these PowerPoints. I recommend you read them. They are going to be the basis for what we do here in Flash and ActionScript 3 over the next few weeks anyway, and before we get into Starling. We're going to hit Starling after we do a couple games, right? Because I want you to start using physics, and I want you to start understanding how to use class files before we get into Starling. Because otherwise, if we do too much at once, there's going to be a lot of confusion.